Section 7.1.17. The random number generator on calculators randomly generates a number between 0 and 1. The random variable x, the number generated, follows a uniform probability distribution. So we want to identify the curve of the uniform density function. So here is our density function. Okay, the first thing is we want to find the area of what's inside this rectangle. So we need to know what is the length and what is the width. Well, if we look at the width, this goes from 0 to 0.8. So the width is 0.8. And then if you look at the length is going to cover from 0 to 1, so the length is 1. So the area under the curve is, which is the area which is equal to the length times the width, is equal to 1 times 0.8, which gives us 0.8. Now, this is not a valid probability density function because the total area under the curve of the equation over all possible values of the random variable must equal 1. So the area under the curve must equal 1. In this case, it doesn't. It equals 0.8. Now, let's take a look at this density function. Okay, we want to find the area of what's inside here. Well, if we look at the width, this now goes from 0 to 1. So the width here is 1. And if we look at this length, we can see that it goes from 0 to 1. So again, to find the area under the curve, the area is going to equal the length times the width, which is equal to 1 times 1, which is equal to 1. And so therefore, this is a valid probability density function. Okay, the next question says, what is the probability of generating a number between 0.4 and 0.7? So using this valid density function, what we want to do is we can see that we want to create this rectangle. And this rectangle is what's inside this density function because we want to look at the values between 0.4 and 0.7. So that tells us what the length of this rectangle is. And the length of this rectangle is to take 0.7 and subtract 0.4, which gives us 0.3. And we can see that the width is 1. So the probability is the area that's between 0.4 and 0.7. So to find the area of that, the length times the width, we know that the length is 0.3. And we multiply it by 1. So therefore, the answer is 0.3. So the probability of generating a number between 0.4 and 0.7 is 0.3. Or if we wanted to write that as a percent, we would take 0.3, multiply it by 100%, and therefore that would be 30%. So 30% would be the probability of generating a number between 0.4 and 0.7. Okay, now what is the probability of generating a number that is greater than 0.79? So when it says greater than 0.79, we know that the total area is going to be 1. So 1 represents the total area because that's what it's supposed to be for the density function. Okay? And we want to subtract 0.79 to determine what is the probability of generating a number greater than 0.79. Well, that would be 0.21. Or we can say that this represents 21%.